But you see, the Earth is in the middle between Mars and Venus. But Venus should not be so hot. It should be warm, but not 900 degrees Fahrenheit.
Was the Big Bang truly the beginning of everything? Or could there have been something before the birth of our universe? Renowned British physicist and Nobel laureate Roger Penrose has a bold answer. He believes our universe emerged from a previous one, and not just once. According to his theory of conformal cyclic cosmology, this is a repeating pattern, universes giving birth to new ones, over and over again. What's more intriguing is that recent data from the James Webb Space Telescope seems to lend some credibility to this idea. According to new findings, it's possible that our universe didn't arise in isolation, but may have merged with another cosmos. Now, according to standard theory, time itself began with the Big Bang. In that view, asking what came before is meaningless, like asking what lies north of the North Pole. The late Stephen Hawking famously supported this stance, asserting that the Big Bang was a self-contained event needing no cause. The laws of physics, he argued, allow a universe to arise spontaneously, from nothing, without any trigger, energy, or divine force. So far, so accepted, but not all scientists agree. Many argue that the Big Bang theory leaves important cosmic questions unanswered. For instance, why did anything come into existence at all? Why did matter suddenly burst into being 13.8 billion years ago? Was it random? Was there a deeper cause? Then there's the puzzling uniformity of the universe. No matter where we look, matter and radiation are evenly distributed, something the Big Bang alone doesn't fully explain. The solution offered? Cosmic inflation, a theory suggesting the universe expanded faster than the speed of light just moments after its birth. During this burst, the universe grew by a factor of up to 1 less than blink. But what if even this picture is wrong? What if the universe's history is far more complicated, and perhaps even cyclical? The James Webb Telescope has discovered several anomalies that don't align with our current models. One such anomaly is the existence of the so-called universe breakers, galaxies that appear fully formed and massive only 300 to 400 million years after the Big Bang. That shouldn't be possible. Our current models suggest there wasn't even enough matter at that time to form such complex structures. Webb has also detected early black holes with inexplicable mass and found inconsistencies in the universe's expansion rate, which is faster than predicted. All these discoveries challenge the very foundation of modern cosmology. So what if we've been wrong, not just about the rate of expansion or galaxy formation, but about the very origin of the universe? Could it be that our universe isn't the only one? That it was preceded by another and will one day give rise to the next? We may be witnessing evidence that the Big Bang was not the beginning, but merely one chapter in an endless cosmic cycle. If you're fascinated by the possibilities of what came before time, be sure to subscribe and stay tuned. The universe may be older, deeper, and more mysterious than we ever imagined. While the Big Bang theory remains the dominant explanation for the origin of the universe, it's far from being the only one. In fact, several compelling alternative theories challenge the idea that the Big Bang was the absolute beginning of everything. One such idea is the concept of the Big Bounce, a theory that suggests our universe didn't begin from nothing, but instead emerged from the collapse of a previous universe. In this scenario, the Big Bang wasn't the start, but rather the transition between two cosmic cycles. This notion of cosmic rebirth isn't new. Many scientists have long speculated that if the universe can expand, it might also contract and then begin again. Such cyclic models remain popular for one major reason. They help solve the causality problem. If matter has always existed in an eternal cycle, then there was never nothing, and we no longer have to explain how something came from it. The striking uniformity of the cosmos could also be accounted for by contraction phases that smoothed out matter before expansion. In this view, the cause of the Big Bang is simply the end of the previous cycle, kicking off a new round of expansion. Roger Penrose, the famed British physicist and Nobel Prize winner, is a key proponent of this cyclical perspective. According to him, the universe will expand indefinitely until all matter decays into light. In this strange, timeless state, space and time lose their meaning, paving the way for a new universe to burst into existence. Even more intriguing is Penrose's claim that he has found physical evidence supporting this model. He and his team identified circular features in the cosmic microwave background, CMB, remnants of heat from the early universe that may be leftovers from a previous cosmic era. These circular zones, called Hawking points, were detected using data from the Planck and WMAP satellites. They represent anomalies in the CMB that match predicted temperature fluctuations from decaying supermassive black holes in an earlier universe. As these black holes emitted Hawking radiation, Penrose suggests their energy transferred into the next universe, appearing in ours as glowing disks about the size of the full moon. But that's just one hypothesis. Another exciting idea comes from chaotic inflation theory, which suggests that our universe is just one bubble in a much larger, eternally expanding multiverse. In this model, inflation only stops in localized regions, forming self-contained universes, like ours. Even more astonishing, a study published in the Journal of Cosmology and Astroparticle Physics suggests that our universe may have actually merged with another universe in the past. This brings us to the Hubble tension, a puzzling disagreement in how fast the universe is expanding. Theoretically, we should observe a Hubble constant of 67 kilometers per second per megaparsec, but measurements using supernovae, gravitational lenses, and Cepheid variable stars yield a significantly higher value of 73 kilometers per second per megaparsec. To investigate this further, the James Webb Space Telescope examined 320 Cepheids. Its results confirmed the higher expansion rate, ruling out earlier measurement errors. So what gives? One groundbreaking explanation is that our universe is interacting with others, merging, colliding, and growing as a result. Some researchers even suggest that our universe was born by being swallowed by a larger mother universe and has been merging with smaller baby universes ever since. Using mathematical models, scientists simulated what interacting universes would do to our own, and they found that this process could explain the observed volume growth and expansion rate more accurately than the standard model. Of course, we can't observe other universes directly, but we might detect their influence. Researchers are now focusing on the CMB, hoping it contains more clues, perhaps even new anomalies, or unexplained patterns that hint at inter-universal interactions. So who knows, maybe the secrets of the multiverse are hiding in plain sight. And speaking of unlocking new worlds, click like and subscribe so you don't miss the next mind-bending discovery from the edge of the cosmos.